Wayne and Orson. I work at CERN, and today I wanted to present you a feature we recently developed. That is integration of a spice simulation engine into Kicad. I'll start with a quick agenda. So first I will give you a bit of background, what were our goals and what features we currently support. Then a bit of technical details, how we did that, followed by a to-do list, and then a live demo. Hopefully it will work. So, how did we start with, where does the idea come from? So it was essentially a quick hack that turned into a useful feature. Sometime last summer we accidentally discovered that ngSpice can be built as a DLL. It was actually some Python guy who made a very nice API and turned ngSpice simulator into a shared library for the purpose of processing signals within a Python based framework. But we thought, well, this is an easy way of integrating a simulator into a CAD application. And our aim was, well, why don't we try making something that looks and feels a bit like the, well, non-free but industry standard LTSpice, but in Kicad. So, our goals were to have a simulator integrated into the Schema, which is, well, the fancy name for the Kicad schematic editor, that is compatible with Spice models, that is reasonably easy to use, so, well, ideally one click to run a simulation, and that in the longer run allows for the choice of the simulation kernel. Currently we support only ngSpice, but this will likely change in the future. So, what do we support so far? We can run operating point, AC and transient analysis. We have our own built-in plotting application. We also support live voltage and current probing. So once the simulation is running, you can basically click onto a component or a wire on the schematic to automatically update the plot with the corresponding signal value. Think of it as a virtual scope probe. And another nice feature is that we can adjust the values of the RCL components in the real time. And this lets you observe as the operation of the circuit changes when live. So, how did we implement it? Basically, the simulator is a separate Kicad application that is linked together with the schematic editor. So we have two editor frames, the schematic frame and an associated simulator frame that runs in a separate window. And then they both use an abstract class called Spice Simulator, which provides an abstract API that is simulation kernel independent, provided that the simulation kernel supports a Spice compatible netlist. Then we specialize that class, for instance here, to ngSpice, and then we use libngspice.so or ngspice.dll, the dynamic library, using its native API. This way we can provide as many backends as we want, right? So, what is on our to-do list? It's still an experimental feature and it lacks a lot compared to Cooks, for instance. So we would like to add more analysis types, for instance, transfer functions, noise analysis. The plotting app is a bit quirky for the moment, so it deserves a bit of user interface fixes. We also like to have storage of the simulation sessions in files. We need to work on the printing and PDF export. And, well, one ambitious feature that we don't know if it will ever happen is support for microwave simulation, probably through another kernel like Cooksator, and support for EBIS models for signal integrity simulations. Then the last point, is about live tuning of also sources and parametric variables, as we currently only support RCL components. So I'm going to make a short demo showing basically I will draw a simple circuit and simulate it just to show you how it looks like. Before that, well, under Windows, you just need to download nightly. I think the same applies to the OS X. It comes already with built-in SPICE support. Under Linux, you need libngSpice installed, and most likely you need to compile from the sources. So here are the magical incantations to do that. Just remember to have libngSpice installed. It's available on most distros as a package, and remember to be it with the Kicad_spice flag enabled. Okay, so it's time for the demo. So let's try designing something simple, like a rectifier or something like this. So most SPICE components are in the pSpice library. So let's take a voltage source. And then in order to edit its SPICE parameters, we need to go to the properties and select Edit SPICE Model. And here you have a user-friendly way of entering all the sorts of source or component parameters. So let's say 5 volt sine of 1 kilohertz. Then let's add maybe a resistor, maybe another one, a diode, and some capacitor for smoothing. And now, well, some values. Let's keep them more or less reasonable. And wire it all together. Of course, we need to add a ground net because every simulator needs that as a reference node, otherwise it won't work. And let's annotate the schematic so that every component has a unique name. Yep. And maybe label a bunch of wires. I'll save current sheet as. Okay, so now in order to launch the simulation, we have our simple circuit done. Go to Tools, Simulator. And then, well, it's easy. Run and stop simulation. Well, it reminds me that I forgot to select the analysis type and duration. So yeah, we need to go to the settings. And let's write transient. So let's say 10 microseconds time step, 10 milliseconds total. Run. So no errors. So now let's observe some signals in the circuit. For that we have either the add signals option, where you can basically pick from all the nets available in the design, or we can use the probe tool. But for some reason it is all flat. Did I do something wrong?
Did you specify V1?
Hmm?
Did you specify V1?
Yeah, I think so. Edit spice model, transient sinusoidal. Strange. Maybe I forgot to save it, so it defaulted to 0. Okay, now it should work. So yeah, let's restart the simulation. Voila. But the ugly thing is that I connected the diode with this polarity, but there is something wrong. The plot is upside down, right? It's in the negative half. So, you know, there was a common problem with Kicad libraries when the transition was done between one version of library and the other. And this changed the node mapping. So, fear not, in the SPICE model editor we provided the means for overcoming such problems, and also for adapting your symbols to SPICE models which might have arbitrary terminal sequence. So here we can invert this, and this applies to all the components. So now it's as it should be. What else? So I mentioned that we have live tuning of the component values, so let me show you how it works. So we can pick the screwdriver tool here, and then let's say we want to see how the operation of the circuit changes as we change the capacitor value. So a slider appeared here. Let's increase the range a bit to like something like this. So as we increase the capacitance, the signal becomes flatter. Yeah, so this is not only a nice feature, but also something that can be used in education by the teachers to show people how the operation of the circuit changes as they mess around with the components, all in a simulation. Let me show you another circuit, just quickly. Okay, I think this is not maybe not needed. So it's basically a simple filter. So here we can also run AC simulations and use the tuning feature to design filters without too much math. So as I change the capacitor value, the transfer function also follows. And basically, that's all I wanted to show you. If there are any questions, I'm happy to answer them. Thank you.
You still have time to show how you got the model for that op-amp.
Oh, yeah. So, where is it? I forgot to mention one important thing. So this is a macro. This uses a macro model of an op-amp, and it's quite easy to select. So to assign. So you need to edit the SPICE model, go to the Integrated Circuit tab, select a file with the corresponding IC, and then in this drop-down box, all the models that are in that file will appear, and you just select it.
SPICE model from
Yeah, standard SPICE model. In this case, it comes from Analog Devices. Right, any questions?
Can you still add the spice directly straight into the schematics?
So the question was if I can add spice directives straight to the schematics. Yes, we can. In fact, we even have one here.
Another question as well about that is can you export the spice netlist for archiving?
Yep, you can export a spice netlist from Kicad. So it's tools, generate netlist file here. So you can use it with any external simulator.
What frequencies can you put in the white noise as the input and melody frequency response as a block result?
I didn't try, but whatever. So the question was if I can put white noise as the input and see the frequency response. So you can do whatever the ngSpice provides. I never tried this in particular, but yeah.
At the implementation level, are you generating a spice netlist and feeding that to the simulator core as a text, or are you driving the simulator feeding it as sort of direct netlist?
So the question is if we are generating a text netlist and passing it to the simulator, if we are doing it in a, let's say, more binary way. So we just use text. The data is extracted basically as tables in the memory, but netlist is parsed the normal way and passed to the simulator.
But the thing is, it's not like you save a file and you load it somewhere. There's an interface for an Enterprise library that allows you to issue the whole netlist using a function provided by the library.
Can you repeat that?
You did a Python interface over the ngSpice library, and then you're using the Python interface, isn't it?
No, we don't use Python in the schematics editor yet.
Oh, okay.
Okay, let me repeat. So Orson, the co-author of the simulator feature, said that we are not using files for passing the netlists. Instead, the API provided by ngSpice basically inputs a netlist as a string, as a big string, and that's it. So there is no intermediate files. And now there was another question.
If you did a Python wrapper over the ngSpice.
Whether we did a Python wrapper over ngSpice. No, we did not. It's pure C++.
More questions?
Yep.
When you tune a component, does the program have to rerun the entire simulation? For example, if you have a very complicated circuit, do you have to expect to rerun the circuit every time you tweak a value?
So the question is if we do have to rerun the entire simulation in order to tweak a value. It depends how ngSpice handles it, because when you change the component value, I don't think it reruns the entire simulation setup completely. It just reruns the transient part, or okay, so somebody says yes, it does. But well, computers are fast these days, and for AC analysis or relatively simple circuits, it works quite in real time.
More questions?
One back here.
Attila?
Yes.
Are there any plans to annotate the schematic symbols with the SPICE model so that you just put your schematic together and then think, okay, I'll let me simulate that, and I don't have to specify any SPICE stuff anymore, just add sources and have my output?
So the question is if there are any plans to annotate schematic symbols with the SPICE models. I wish there were, but I don't think there are any such plans for the moment. This heavily depends on the library managers. Wayne, would you like to add something?
Just on that topic, it kind of falls in the same scope as the classic atomic symbol, where we have a fully defined part number, and you know, if people provide them, then we would have them for our libraries. But I don't think that's something, because you know, there's thousands of op amps. We have a common op amp symbol, so you're going to have to go find the SPICE model and then add that. We would be outside of the scope of our normal libraries.
Yep.
because otherwise now we have to say this symbol is an 80 whatever, and this op amp from analog devices. We have to match up with that splice model. It would be prohibitive. It would
Yep.
be expensive for us to do that in prime market.
Yeah, so in short, people have their own library standards. Every company, every designer uses, calls their components in a slightly different way, so there is no gold-plated solution to have, like a single simulation library that will match everybody's requirements.
More questions? Yes?
Yep.
So is it possible, based on the schematic, to run the simulation in the command line? So on a headless system, where you can just take the schematic and whatever parts of ngSpice code you have separately, and then run it entirely on a headless system?
The question was if it's possible to run the simulation from a command line on a headless system. Well, you can always export a SpiceNet netlist and run ngSpice from the command line.
Yeah, but then you first have to open it in Kicad, which is not able to run inside on a headless system.
Kicad is a graphical application.
How does it handle communication between the scheme software and the Spice window? Because like you have the back and forth when you probe the circuit, like it switches automatically between the schematic and the simulation.
So the question.
Like a communication protocol or inter-process communication?
So the question was, how do we communicate between the simulator window and the schematic editor window, whether we have some IPC protocol. There is no protocol because they both run, the GUI runs in a single thread, the simulator runs in a separate thread, and all the communication between the windows is passed through standard VX widgets events.
I did want to add on that the last previous question about running simulations. Right now, the Python scripting hasn't been developed yet for the schematic editor. That's going to be in version 6. So at that point, you'll be able to just create a script and tell the schematic, just say, hey, here, I'll load this schematic file and dump it and run it automatically. So you'll be able to do that with Python eventually. But the board, you can do everything with the board file now, but the schematic editor still, we haven't implemented the Python scripting. We haven't swigged that out yet. But it's coming.
Okay, so Wayne just mentioned that in the version 6 we will also have Python scripting support for the schematics, so this will allow any sort of processing of the schematics to be done from within a Python script, including perhaps simulation.
Questions?
Any questions?
Okay, so Tom again.